Okay, what I would like to do now is we did some practice problems today in class from the PowerPoint, and I'm going to do those same problems again and just kind of go back through and talk through the rationale why we put what we put. This first question says the principal quantum number n, and again, when we see n, we want to think of that as energy levels. And we can really think about the periodic table, and again, row 1 is energy level 1, row 2 is energy level 2. Can have values of what? Well, again, go back over here and think about what's the very first value. 1, 2, 3, 4, 5, 6, and 7. That is all that n is referring to. So do not complicate that very first one. That one's pretty simple to think about. 1, 2, 3, 4, 5, and then of course we could go 6, 7. The next one says that angular momentum quantum number L can have energy values from what to what? Integer values from what to what. And if you look back at those notes we took just a moment ago, here's that L value. And remember, this is that subshell. So when you see L, you should be thinking of the S, P, D, F sublevels. And we see that it can have a value anywhere from 0 to 3 for Honors Chem 1. And so we're going to go ahead and fill that in. And if you kind of wanted to come over here and make yourself a note of that, that may not be a bad idea to do. The next question says the magnetic quantum number can have integer values from what to what. This is the one, again, that students usually tend to struggle with. And if we look back at what we discussed a moment ago, we said that that looks back at the orbitals. We have to understand that the s orbit has one orbital here and that it's given a value of 0. The p sublevel has 3 orbitals. The D has 1, 2, 3, 4, 5. That's 5 locations where I can put an electron, and the F has 7. So in looking at this, the largest one that we'll be talking about could range from -3 to +3, and that's what we are going to plug in right here. Okay, so let's look at what the practice actually looks like for this. It tells us if n is 3, L can have values of what? Well, we would need to look back over here, and you see that you've got 3s, 3p, 3d, and let's look over here. What could potentially L have? Well, we said that there was a 3s, a 3p, and a 3d. I see s, p, and d, which means 0, 1, and 2. So L could potentially have values of 0, 1, and 2. It's specifically asking about the 3D sublevel. L has a value of what? So let's think about 3D. We understand that D has 5 orbitals, 1, 2, 3, 4, and 5. We understand that they range from -2 all the way to a +2. Therefore, L could have a value of what? Anywhere from -2 to +2. It could be anywhere in between there. The next one says when n equals 4, L can have values of what? So again, let's come back over here and take a look at what we've got. You see you have 4s, 4p, 4d, and 4f. So in this we have actually 4 possibilities. Thinking about 4s, 4p, 4d, and 4f. Okay, L could have how many values? That would be 0, 1, 2, and 3, because remember what we said over here. S is representative of 0, P is representative of 1, D is representative of 2, F is representative of 3, so 4S would be 0, 4P would be 1, 4D would be 2, 4F would be 3. And so we'll write 0, 1, 2, and 3. Specifically, the 4p sublevel, what could that L potentially have a value of? Well, we're talking about this one right here. We said that the p can hold, it had 3 orbitals, and each one could hold 2 electrons, okay? And that would range from 0, that would be a +1, and that would be a -1. So it could have values of anywhere from -1 to +1. Okay, So anywhere in between there. The last one says when n equals 2, L can have values of what? If we look back at this sheet, we see that there's a 2s and a 2p. It stops right there. So let's think about that for a second. 2s and 2p. L can have values of what? Well, s is a 0, p is a 1, so it can either have a value of 0 or 1. If we're talking specifically about the 2s sublevel, L can only have a value of 0 because we understand that the 2s only has that one orbital there. It can only hold 2 electrons, and that's the only possible value that it can have. In summarizing, really focusing in on that value of L and what does that mean, again, because this is kind of the difficult one for students to understand. Each one of those orbitals is assigned a numerical value. Here we understand that the S represents 0, the P is a 1, the D is 2, and the F is a 3. That's just basic numerical information, math problem, assigning values to letters. And then let's go ahead and work through 4, and I'll stop right there for this tutorial. It says there are 5 4D orbitals. We kind of said that earlier. This is 4D. We understand that D has 5 orbitals, 1, 2, 3, 4, and 5. List the quantum numbers for each orbital. Well, that right there is your principal quantum number. So the n value is going to stay the same for all of them. It would be 4 all the way down. We are talking about the d orbital. And if you look back up here when we wrote down, we said that the d orbital, I'm saying d orbital. The d sublevel has a value of 2. Therefore, for L, you're going to see me write in 2's all the way because that is telling us that we're in that D sublevel the whole time. Here is where I kind of want you to stop and think for a second. We've got to assign a numerical value to each one of these orbitals. And if you can start kind of thinking about it as a number line, the 0 is always going to go in the middle and then work your way forward. Positive 1, positive 2, negative 1, negative 2. So all of the values over here could range from a negative 2, negative 1, 0, positive 1, positive 2. Okay, so that is those are our principal quantum numbers, our magnetic spin, our angular momentum, and our magnetic quantum numbers for that one.